All right, now that we've classified eruptions, let's classify volcanoes. So volcanoes that are fairly small, we call those cinder cones. As volcanoes grow in size, if they are very pointy, we call them stratovolcanoes. If they're more flat, kind of like a shield, we call them shield volcanoes. And each one of these shapes of volcanoes is produced because they have a different composition of magma. Right, so composite volcanoes, also called stratovolcanoes, are the same thing, just different words. These volcanoes have magma with really high viscosity, meaning it resists flow. So because it resists flow, the magma stays up near the top of the volcano, creating a very high triangular shape volcano. Because this magma is viscous, it resists flow, that's the one that produces the really explosive eruptions. Right? So we typically think of volcanoes, when we picture volcanoes in our mind, we think of them as triangular with huge eruptions. So you're thinking of a composite volcano. But you can also have shield volcanoes. Shield volcanoes are those that have low viscosity magma. So for example, a basaltic magma that's very runny, flows for long distances. So when the lava comes out of the volcano, rather than sticking up near the top, creating a point, it's going to flow for long distances, creating more of a dome-shaped volcano. And these shield volcanoes have effusive, runny, low viscosity eruptions. The last one we're going to talk about is the cinder cone volcano. These are pointy, right? But they're smaller than stratovolcanoes, and they more often have that typical bowl-shaped crater in the middle. So cinder volcanoes or cinder cones are steep conical hills of loose pyroclastic fragments. I've hiked up one of these. It's very difficult because it's like every step you take up, you fall back down because it's just loose rubble. So cinder cone volcanoes. Now, when I talk about volcanoes erupting, often we think of the eruption coming from the top, the summit of the volcano, and we call that the volcano crater. That's the bowl-shaped depression at the top of the volcano. Right? But lava doesn't just erupt from the summit at the crater, it can also come out of the flanks. So there are other cracks in the volcano where you can get flank eruption or vent eruption. But when the magma does come out of the crater at the top, right, all of that pressure at the top is released, and that's what allows the bowl shape to form, right? The volcano erupts, pressure is released, and then it subsides back down, and what used to be magma is filled in with earth, creating that depression. And when that depression is very, very large, we call the crater a caldera. Okay? So Yellowstone is an example of a volcano that has a caldera. Supervolcanoes, again, these are huge volcanoes. They are those with volcanic explosivity indexes of 8, the largest recorded value ever in the history of the index. And this means the volume of deposits that are coming out of these eruptions are thousands of cubic kilometers, right? So Yellowstone is a really great example of that, where when this supervolcano erupted, it covered the majority of the United States.